go back to something a little bit more matte over here. That'll look nicer probably. Okay. So now another thing I'm going to show you, other than this sort of more realistic render, I'm going to bring up, show you how displacements work in MachStudio. So one of the things that we do with MachStudio Pro is the package currently sells, we sell it with the highest end ATI GPU, which is the 8750, which is a 2 gig card. We're really, really happy with it. We have a number of optimizations that are absolutely specific to ATI, and that's why the basic package comes with an ATI. When we sell it together, it actually is an amazing deal on the card and the software together. But the reason that we like the ATI stuff is, other than the fact that it's natively 10-bit color internally, what we can do with displacement and tessellation is out of this world. So I'm going to demonstrate that for you right now. And what's important to understand about, and I've gotten jaded looking at this, but currently if you're doing a CG production, if you actually want to take like a ZBrush model, and you're actually going to use that stuff for displacements, and you pass it through your ray tracer, that like multiplies your, because it has to create so many polygons, so many triangles. So part of what we do is we've created a subpixel displacement system. It's attachable to any one of our materials. You just go in and say, I want to use displacements. And you, from a workflow standpoint, we allow you to bring in TIFF or HDR files that are exported via Mudbox or ZBrush. And both of those programs create beautiful float displacements, and we use those. So I'm just going to demonstrate that to you. Let's open up the material. So I'm selecting that material again. It's a blend-based material. Very quickly, just let's look. It's kind of a standard little this rock texture that we created on here. I'll show you the geometry first. Okay, so I'm going to turn on the tessellator. So that's the first thing I did now is I turn it on. It's already reading in the displacement map I have on here that I basically am controlling. I can just control live. But here's the thing that's going to really be fun to see. So let's just tessellate. So this is pretty amazing because we are running scenes here with a displacement map, several billion polys easily. So you can see how you can build a scene that's using like low to medium resolution polygons. You do your fine detailing in ZBrush or Mudbox. You bring it in here and you let MachStudio essentially fill in the final definition based on what your modeler slash 3D ZBrush Mudbox artist did. Now further, there's one more thing I need to show you, a few things I need to show you here. But this is also running, I can start it running Catmull-Clark. So, oh, it wasn't Catmull-Clark. This is without Catmull-Clark, so it's does a different algorithm, or with Catmull-Clark, it does a different algorithm. So it supports the sub-D definition on your surface. Now check this out. Then you're looking at geometry here, so let's actually get out of geometry. And let's actually bring the tessellation up on that, and this will be really fun. So now I'm actually using the displacement. So that geometry, and I'll render it really quickly. That surface is purely being generated by the displacement map and the tessellator. And it's pretty damn cool, actually, because what you can do is you can start building multi-shaders with these things. And now, so that surface, let's zoom in on that a little bit. Let's zoom in on this a little bit. I don't need to tessellate to that level, I don't think. There we go. Again, like anything else, you can go to higher levels of render, so this is really fun. So just to show you how this works, we have this kind of natural-looking terrain, and I can do some interesting effects right in here, blending between these two materials and displacement maps. And again, all this can be animated, so you can let your imagination run free if you start to think about what happens when you start running animated displacement maps with different materials and so on. You can start to do some very interesting work. What? Oh, great, AO. Okay, this is a fun thing. We always love to show this. So again, if you were doing a final gather on a 1 billion, well, even forget it. This is now 32 million polys, by the way, when I do this. The last I looked at it, almost at full tessellation. If you were trying to do a final gather on a 32 million poly surface, you're going to wait quite a bit of time. For us, this is automatic because of the way we run this. Watching AO is responding always to the conditions of those displacements. There's absolutely no wait time. Let's make that nice and contrasty so we get the full effect. That occluded light is actually happening live. Oh. slide it. That's pretty neat to see. The geometry absolutely working live in MachStudio. And I'll go to a higher sample so you can see it a little bit cleaner, and so on. All right. What didn't I show? That's pretty much. There's more, but there's always more. So just to recap, just philosophically, what we're trying to create is essentially an application that allows for creativity to be put back into the CG process at an extreme level. So I mean, something that we like to say is we call this almost like Photoshop in 3D, in the sense that what used to take to put a single page of printed material 50 years ago, literally you have 20 people working on it, all the way from your art director to the guy setting a font in a 100,000-foot factory with printing presses. And frankly, the rendering process looks very much the same today. You have modeling animation that's passed to shader TD, that's passed to lighting TD, that's passed. The shop is kind of fragmented across all these skill sets, and it comes back together in comp. And artistic interventions are expensive, and obviously it affects the business, everybody's business model in the room. What we're hoping to do is to take an application that is focused specifically on the visualization problem. That is, what do we do with material? What do we do with lighting? What do we do with camera exposures? And how do we prep it for comp? So it takes a really big footprint. That's why we call it finaling and 3D compositing. That's kind of the, it's kind of like your 40% of your pipeline can be affected by this. And an important concept I want to always say, I love saying this when I do presentations, in the end, any render, a pixel just has an RGB value. Whether you get to it through rasterizing or ray tracing, a pixel just has an RGB value. And my training was as a painter originally, before I became a scientist, which is a weird thing altogether. And I know that the decision I make has to do with a choice of how I want, artistically, the image to read. And I think in some ways we've become too reliant on simulations to give us the results. Not to say that simulations and processes have their place, but we really want to put the power back in the hand of the artist in terms of making that decision of what color is that pixel. From broad brushstrokes to specific brushstrokes. And that's kind of what the tool aims to do. That's it.